Imagine watching an electron collide with a photon. Straightforward interaction, correct? A photon approaches, the electron captures it, moves along, eventually releases another photon. We label this light scattering. But when physicists construct diagrams and perform calculations for these interactions, they're forced to include some genuinely peculiar scenarios. The electron might release a photon first, then absorb one afterward, already counterintuitive, but buried in the mathematics lies something far more unsettling. The electron releases a photon. Then, and this is where reality gets weird, it journeys backward through time to capture a photon before proceeding forward through time once more. Yes, backward through time, not as some abstract mathematical convenience, but as something real, something measurable, something you can actually detect in a laboratory. The trajectory of this time-reversed electron can extend far enough to manifest as genuine physical phenomena in actual experiments. Think about the implications for a moment. We're not discussing computational shortcuts or useful fictions that make the math easier. We're discussing something you can observe, quantify, verify with instruments. Now, when you observe this time-reversed electron while your own timeline moves forward normally, here's what happens. The backward-traveling electron appears identical to an ordinary electron, except for one critical difference. It's attracted to normal electrons. We describe it as having positive charge. Had I factored in polarization effects, it would become clear why the charge signature for the time-reversed electron appears inverted, making the charge register as positive. For this reason, we call it a positron. The positron is a companion particle to the electron and represents an example of an antiparticle. And here's where the implications become truly staggering. This phenomenon is universal. Every particle in nature possesses an amplitude to travel backward through time and therefore possesses an antiparticle. Every single one without exception. Long before anyone comprehended why, Dirac predicted that alongside electrons there must exist another particle called the positron, discovered at Caltech by Anderson, that is fundamentally linked to the electron. The narrative of this prediction is remarkable. Dirac simply followed where his equations led, even when they appeared to predict something impossible, something that violated common sense about how particles should behave. All the properties of these two particles follow certain correspondence rules. The energies are identical. The masses are identical. The charges are reversed. But more significant than anything else, far more significant, the two of them, when they encounter each other, can annihilate completely and convert their entire mass into energy. Gamma rays. Usually the positron is designated as an antiparticle to the electron, and these are the defining characteristics of a particle and its antiparticle. This wasn't merely theoretical speculation. When Anderson discovered the positron in cosmic ray experiments, it confirmed Dirac's radical prediction and opened an entirely new framework for thinking about particles. The mathematics had predicted reality before reality revealed itself to observation. It became evident from Dirac's reasoning that all the remaining particles in the universe should also have corresponding antiparticles, for instance, corresponding to the proton. There should exist an antiproton, which is now symbolized by a P with a bar over it. The antiproton would carry negative electrical charge and the same mass as a proton, and so forth. The most crucial feature, however, is that a proton and an antiproton encountering each other can annihilate completely. Now, here's where people become confused. And it's worth examining this carefully because it reveals something profound about what anti actually means. The reason we emphasize this annihilation property is that people misunderstand when we say there exists a neutron and also an antineutron, because they ask, wait, a neutron is neutral, so how can it have opposite charge? You see, this question exposes a common misconception. The rule of the anti is not simply that it has opposite charge. It possesses a certain set of properties, the entire collection of which are opposite. Electric charge is merely one property among many. The antineutron is distinguished from the neutron in this manner. If we bring two neutrons together, they just remain as two neutrons. But if we bring a neutron and an antineutron together, boom, they annihilate with a tremendous explosion of energy being liberated, producing various pi mesons, gamma rays, and other particles. The explosion is spectacular precisely because neutrons have substantial mass compared to electrons. When that mass converts to energy according to Einstein's E min c square, you get an enormous release. The products aren't simply photons like with electron-positron annihilation. You get a shower of different particles, a complex cascade of energy transforming into matter and back again. This leads to a fascinating possibility that while it stretches our imagination, if we have antineutrons, antiprotons, and anti-electrons, we can construct anti-atoms in principle. They haven't been made yet, but it's possible in principle. The physics permits it. Only engineering challenges stand in our way. For instance, a hydrogen atom has a proton at the center with an electron orbiting outside. It's the simplest atom, the fundamental building block of chemistry. Now imagine that somewhere we can produce an antiproton with a positron orbiting it. Would it function? Would it be stable? Would it behave like hydrogen? Well, first of all, the antiproton is electrically negative and the anti-electron is electrically positive. So they attract each other in a corresponding manner. The masses are all identical. Everything is identical. The electromagnetic force that binds ordinary hydrogen would bind anti-hydrogen in exactly the same fashion. The quantum mechanics that governs electron orbitals would govern positron orbitals identically. It's one of the principles of physics symmetry. The equations seem to demonstrate that if a clock were constructed of matter on one hand, and then we constructed the same clock of antimatter, it would run identically. The ticking would be identical. The mechanisms would function the same. Every process that occurs in matter should have an exact mirror in antimatter. Of course, if we place the clocks together, they would annihilate, but that's different. Keep them separated and they're indistinguishable. But now an immediate question arises, and it's one that shook physics to its foundation. We can construct from matter two clocks, one which is left-handed and one which is right-handed. For example, we could build a clock that isn't constructed in a simple way, but contains cobalt and magnets and electron detectors, which detect the presence of beta decay electrons and count them. Each time one is counted, the second hand advances. This isn't merely a thought experiment. This is based on real experiments conducted with cobalt-60, a radioactive isotope. The experimental setup is ingenious. You align the nucleus spins using a magnetic field, cool everything to nearly absolute zero to maintain the alignment, and then you observe which direction the beta decay electrons prefer to travel. Then the mirror clock, receiving fewer electrons, will not run at the same rate. So evidently we can construct two clocks such that the left-handed clock does not agree with the right-handed one. Let us make from matter a clock which we designate the standard or right-handed clock. Now let us make also from matter a clock which we call the left-handed clock. We have just discovered that in general these two will not run identically. Prior to that famous physical discovery, it was believed that this was shocking. Genuinely shocking. For decades, physicists have assumed that the universe was perfectly symmetric under mirror reflection. Left and right should be equivalent, but they're not. The weak nuclear force, which governs beta decay, violates this symmetry. Now, it was also supposed that matter and antimatter were equivalent. That is, if we constructed an antimatter clock right-handed, the same shape, then it would run the same as the right-handed matter clock. And if we made the same clock to the left, it would run identically. In other words, initially it was believed that all four of these clocks were the same. Now, of course, we know that the right-handed and left-handed matter are not the same. So we lost one symmetry. The universe distinguishes left from right. But what about the matter in it? Matter symmetry. Presumably, therefore, the right-handed antimatter and the left-handed antimatter are not the same. If left and right aren't equivalent for matter, they shouldn't be equivalent for antimatter either. So the obvious question becomes, which corresponds with which? If either, in other words, does the right-handed matter behave the same way as the right-handed antimatter? Or does the right-handed matter behave the same as the left-handed antimatter? This is the crucial question. And its answer reveals something beautiful about the universe. Now, you might think this is merely an academic curiosity, but it's not. This goes to the heart of how nature operates. We had to perform very careful experiments with beta decay using positron decay instead of electron decay. Beta decay experiments using positron decay instead of electron decay indicate that this is the interconnection matter to the right works the same way as antimatter to the left. The symmetry wasn't destroyed. It just got concealed in a more complicated fashion. You have to combine two transformations, matter to antimatter and left to right, to recover the symmetry. It's like a puzzle where you thought you lost a piece, but it was just hiding under another piece. Therefore, at long last, it is genuinely true that right and left symmetry is still maintained. If we constructed a left-handed clock but made it from the other kind of matter and tin matter instead of matter, it would run identically. So what has happened is that instead of having two independent rules in our list of symmetries, two of these rules combine to make a new rule which says that matter to the right is symmetrical with antimatter to the left. This combined symmetry, called CP symmetry for charge conjugation and parity, became the new foundation. The universe respects this deeper symmetry even while violating the individual symmetries. It's elegant, it's unexpected, and it has profound consequences. Think about what this means. We thought we understood how the universe worked. We thought left and right were the same. Then we discovered they're not the same. The universe picks a direction. But then, and this is the beautiful part, we find that if you flip both things, matter to antimatter and left to right, you get back to the same physics. The symmetry isn't lost. It's just more complicated than we thought. This has profound implications for communication with alien civilizations. Now, this might sound like science fiction, but bear with me because this is a genuine problem. Imagine we establish contact with beings on another world through radio signals. We teach each other our languages, our physics, our technology. We share our cultures, our philosophies, our dreams. Years of communication, decades perhaps. Eventually we decide to meet face to face. But here's the problem, and it's a real problem. How do we define right and left across the void of space? We can't point. There's no up or down in space, no shared reference frame. We can't send them a physical sample. We have to describe it using physics alone, pure physics, nothing but the laws of nature. Before this discovery about parity violation, we couldn't do it. There was no way to distinguish right from left using only the laws of physics. But now we know, and now we know that we can use these beta decay experiments to do exactly that. We can say, look, build this cobalt-60 setup, align the nuclear spins this way, cool it down, measure which direction the electrons prefer to emerge. That direction, that's what we call right. So if our extraterrestrial contact is made of antimatter and we give them instructions to construct this right-handed model like ours, it will of course come out the other way around because of that symmetry we just discussed. Their right will be our left if they're made of antimatter. We tell them, build this cobalt-60 setup, measure the electron directions that defines right for us. They do the same. We compare results. If we get the same answer, we're both made of matter. If we get opposite answers, well, then we have a serious problem. What would happen when, after extensive conversation back and forth, we each have taught the other to construct spaceships, and we meet halfway in empty space? We have instructed each other on our traditions and so forth, and the two of us come rushing out to shake hands, both species excited, both ready for this historic moment. Well, if they extend their left hand, watch out. That simple gesture, that one simple gesture would tell us everything we need to know and give us just enough time to escape. Because if they're using right the opposite way from us, it means our physics experiments gave opposite results, which means they're made of antimatter. One touch and both beings, probably both ships, maybe everything in the vicinity would vanish in a burst of gamma rays, the biggest explosion you've ever seen. All that mass converted to pure energy in an instant. So remember that if you ever meet an alien, do not shake hands until you've verified the beta decay experiments. This brings us back to the fundamental behavior of these particles and the eternal cycle of creation and destruction at the heart of reality. When a particle and its antiparticle collide, they annihilate each other and form other particles. Four positrons and electrons annihilating. It's usually a photon or two, sometimes more, depending on the energy. The energy that was locked up in their mass, all of it, every bit, gets released as pure electromagnetic radiation traveling outward at the speed of light. Think about that. Pure conversion. Mass becomes energy. Nothing left behind. The process is perfectly reversible. Just as matter and antimatter can annihilate to create photons. Photons with sufficient energy can create matter-antimatter pairs. This happens constantly in particle accelerators, in cosmic ray collisions, near black holes, anywhere there's enough energy concentrated in a small enough space. It's happening right now, actually. Cosmic rays hitting our atmosphere, creating particle-antiparticle pairs. Most of them annihilate almost immediately, but we can detect them. And what about photons? This is interesting. Photons look exactly the same in all respects when they travel backwards in time, as we saw earlier. So they are their own antiparticles. You see how clever we are at making an exception part of the rule. A photon moving forward in time is indistinguishable from a photon moving backward in time. So it serves as its own antiparticle. Photons have no charge, no distinction between particle and antiparticle. They're perfectly symmetric in time, completely symmetric. Now, the backwards moving electron interpretation explains something remarkable that Dirac's original theory left mysterious. Dirac said there must be antiparticles, and he was right. But why? Why must there be antiparticles? His theory didn't really answer that. But when you think about particles moving backwards in time, suddenly it all makes sense. It has to be that way. When we see per production an electron and positron appearing from pure energy, we're actually watching a single electron's world line making a U-turn in time. Think about that. The positron isn't a separate particle that was created. It's the same electron now traveling the opposite direction through time. One electron just going back and forth in time. When we see annihilation, we are observing that same U-turn from a different perspective. What looks like two particles meeting and destroying each other is actually one particle's path doubling back on itself in time. The creation and destruction are illusions of our forward time perspective. We're stuck moving forward in time. So when we see something moving backward, we interpret it as a different kind of particle, but it's not. The electron never really appears or disappears. It just changes direction in time. Like a car making a U-turn. Same car just turned around. This picture, strange as it seems, works perfectly. The calculations match experiments with extraordinary precision. We're talking about predictions that match reality to one part in a trillion better than any other theory in physics. Every Feynman diagram we draw relies on this interpretation, allowing particles to zigzag through time, forward and backward, creating the rich tapestry of quantum interactions we observe. We sum over all possible paths, including the ones that go backward in time, and we get the right answer every time. Nature has spoken, and the mathematics is clear. Particles can and do travel backwards in time, and we call their backwards moving versions antimatter. It's not some exotic opposite universe material. It's ordinary matter, electrons, protons, neutrons, moving through time in the direction opposite to our experience. That's all it is. And that simple insight, that one insight, unlocks the deepest secrets of how particles interact, how they're created and destroyed, and why the universe has the structure it does. You see, sometimes the strangest ideas, the ones that sound completely crazy when you first hear them, turn out to be true. The universe is stranger than we imagine. And that's what makes physics so wonderful.